Assalamu alaikum wa rahmatullahi wa barakatuh. Hello everyone, welcome to AB Chemistry. Today we are going to continue on Chapter 1, Atomic Structure and Properties. Mass spectroscopy of elements. Mass spectrometry is a technique used to determine the molecular mass of atoms, molecules in a sample. What we have to do, take the sample, injection. The injection could be through direct injection, GC injection, or LC injection. Then we transfer this sample to the gas phase, ionize it, for example, bombard with high energy electrons, so it will be ions. Okay, these ions will be accelerated, then analyzed, for example, by magnetic field. The ions will deviate based on their mass to charge ratio and detected. Mass spec of some pure elements shows the existence of elemental atoms with different masses. We call them isotopes, which support the existence of neutral, the neutral part of the atom. For example, natural copper is made up of copper 63 and copper 65. Mass spec can determine the ratio of this isotope or identify a sample containing copper based on their ratio. So this is a relative abundance, and we can see that the copper 63 exists in higher percent than copper 65. Let's take an example. We have element Y, mass spec shows 7 different peaks with, of course, different relative abundance: 92, 94, 95, 96, 97, 99, and 100. They are isotopes. Based on the mass spectrum of atom Y, which of the following statements is false? Peak A and peak D come from atoms that have the same number of electrons. That's correct. There are 7 isotopes of atom Y. This is correct. Peak C comes from the most abundant isotope of atom Y. This is correct. Peak D comes from an atom with 4 different protons than the atom that gave peak B. This is wrong because they are isotopes, and the isotopes are different in the number of neutrons. So the correct answer will be D. Identify of Y. Zirconium, molybdenum, americium, and strontium. Well, checking with the periodic table, we will find that the correct answer is B, molybdenum. This compound is molybdenum, and we check that, yes, that is the molecular mass of molybdenum, and these are the isotopes. Which B comes from an atom with the greatest number of neutrons? Of course, will be D, the highest mass. So the answer is D. Because each proton and each neutron contribute approximately 1 atomic mass unit to the mass of an atom, and each electron contributes far less, the atomic mass of a single atom is approximately equal to its mass number, like a whole number. However, the average masses of atoms of most elements are not a whole number, because most elements exist naturally as a mixture of two or more isotopes. The average mass will be equal to the sum of the fraction of abundance times the isotope mass. Example: the element boron is composed of two isotopes. About 19.9% of all boron atoms are boron 10, with a mass 10.0129 atomic mass unit, and the remaining 80.1% are boron 11, with a mass of 11.0093 atomic mass unit. Then the average atomic mass of the boron will be the 19.9% times the mass 10.129 plus 80.1% times 11.0093 atomic mass unit. So that makes 1.99 atomic mass unit plus 8.82 atomic mass unit. So the average will be 10.81 atomic mass unit. Let's take another example. Naturally occurring chlorine consists of chlorine 35 with mass 34.96885 atomic mass unit, and chlorine 37 mass of 36.96590 atomic mass unit, with an average mass of 35.453 atomic mass unit. This is the average mass. What is the percent composition of chlorine in terms of these two isotopes? Well, the average mass of chlorine is the sum of that 35 times the mass of 35 plus a fraction that is 37 times the mass of chlorine 37. So the average mass, as we mentioned, fraction 35 times the mass of 35, fraction of 37 times the mass of 37. Now, let's assume that the chlorine 35 exists in fraction x. The 37 will be 1 minus fraction x. Okay? So the fraction that is 35 plus the fraction of 37 must add up to 1. So the fraction of 37, as we mentioned, 1 minus the fraction of a 35. So 35.453 atomic mass unit will be equal to the sum of x times 34.96885 plus 1 minus x times 36.9659 atomic mass unit. So x will end up to be 0.7576. Therefore, chlorine 35 will be present abundance of 75.76, and the chlorine 37 will be 24.24. See you next session.